So for example number 2, a rock is dropped from a height of 15 meters, ignoring air friction. How long does it take to hit the ground? How fast is it moving when it hits the ground? What's the average speed of the rock during the descent? And we talked about this a little bit to set you up. Now let's take a look at the solution. So since it says the rock is being dropped, we know the initial velocity is 0. And it's being dropped from a height of 15 meters. So we know that the displacement is actually negative 15.0 meters. All right, we're saying up is positive and down is negative. We know that the acceleration of gravity is 9.81 meters per second squared down, or negative. And of course in A they ask how long does it take to hit the ground. So of course since D is equal to VIT plus 1/2 AT squared. This is a kind of a nice question to start with, because the initial velocity is 0, then this term is equal to 0. And so D becomes equal to 1/2 AT squared. And T squared is equal to 2D over T. I isolated, or over A. All right, 2D over A. What I did was multiplied both sides by 2, divided both sides by A in order to solve for T squared. And then, of course, that's equal to 2 times negative 15 meters divided by negative 9.81 meters per second squared. And that's equal to T squared. So T squared is going to be equal to 0.058 seconds squared. But of course we don't want seconds squared, we want seconds, so T is the square root of that, and the square root of 3.058 is 1.748, or we'll say 1.75 seconds. So that is the time of travel. How long does it take the rock to hit the ground? Approximately 1.75 seconds. Now, how fast was the rock moving? Well, let's move over here and say, well, they want to know what the final velocity of the rock was. Now, we can use this information once again. In this case, we don't really care what time is. We can say that the final velocity squared is equal to the initial velocity squared plus 2AD. What you do is you take a good look at the 4 kinematic expressions that you have on the sheet, and you can assess which one would be best suited to this problem. Since we ignore time, since we solve for time in A, but for B they want to know how fast it's moving, final velocity. Since they've given us initial acceleration and displacement, it makes sense to use this formula. And so, of course, again, initial velocity is 0 plus 2 times negative 9.81 times negative 15 gives us the final velocity squared is 2 times 9.81 times 15 gives me 294.3. So we have 294.3 meters squared per second squared, and that's VF squared, so VF is going to be the square root of that. Square root of that is 17.155. 17.155 meters per second. And of course, logically, we know that it's down, so it's actually our solution should be negative 17.2 meters per second, or 17.2 meters per second down. All right? And then the last one, what is the average speed? Well, the average speed, of course, as we mentioned in the problem, the average speed is just the final plus the initial divided by 2, and in this case it's negative 17.2 plus 0 divided by 2. And so you get half of 17 by 2. It is 8.58 meters per second, and of course that would also be down, 8.58 meters per second squared, and of course it's down. So, but since they're asking for speed, you don't actually have to give the direction. Same with this one. They actually mention how fast is the speed. If they want velocity, they have to be more specific. But there's a solution to A, 1.75, B, negative 17.2, or just 17.2 meters per second, and C, 8.58.